So 2.5, using linear models. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. You can use scatter plots to determine the strength of a relationship, also known as the correlation between data sets. The closer the data points fall along a line, the stronger the relationship, and the stronger the positive or negative correlation between the two variables. So here we have some examples of various scatter plots. And as we look at this, we should see from the first graph, these points all look fairly close together. They're grouped along a line fairly nicely. And so we would say that this has for the most part, a strong correlation. If we were to draw a line, you notice they're kind of close together. And then we would say this has a strong negative correlation because the slope of the line in which we would overlay here is decreasing. In the second picture, notice here that if we were to lay a line across this, the points are more spread out. This would be considered a weak correlation. And because of the slope of that line, we can say this is a weak negative correlation because the values are decreasing from left to right. Then, for the middle one, notice that there's not really an indicator of any kind of line or system to this, so we would say that this has no correlation. And then as we move along, here we've got some points that are fairly spread out. They're not tightly grouped together, so this would be a weak correlation, but because the graph or the values are increasing, this would be a weak positive correlation. And then last but not least, we have our strong positive correlation. Here we have an example of using a scatter plot. All right, so the table lists the average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. They're then asked to make a scatter plot and determine how we would describe the correlation. So this is the information they're given. This is the data they're using. So they've got information for the average temperature, the month, as well as the bill. And so we're going to look at comparing average temperature to the electricity bill, and then we're going to create a scatter plot from that. And this is just an example. It's already been done for you. This is the scatter plot created. And then they asked to describe the correlation. And so looking at this particular scatter plot, it's fairly straightforward that as the temperature increases, the electricity costs also increase. And since the points are also fairly tightly clustered together, we can say that this has a strong positive correlation. So there's a strong positive correlation between temperature and electricity cost. So the goal here is to make a scatter plot and then examine your points to see how you feel they relate. So what kind of correlation are they dealing with? As one value increases, is the other increasing? Are the points grouped tightly together? If so, you have a strong positive correlation. All right, here we have a practice problem. It says the table shows the number of hours students spent online the day before a test and the scores on the test. Make a scatter plot. How would you describe the correlation? All right, so the first thing we want to do is just create a scatter plot for this information. All right, so there's my scatter plot. I have, on the y-axis, I have scores. On the x-axis, I'm using hours. And so as we can see from the data, it's fairly close together. Depending on how big your scatter plot is, you might see some variance here. But the points are very, very closely grouped together, almost close enough to form a line, not really. But they are closely formed together. And we do see that as the number of hours increases, the score decreases. So as the hours increases for the spent time online, the score decreases. So with that, we know we have a negative correlation. And because our points are grouped closely together, I would say that for this one, we're looking at a strong negative correlation. The second part of this question says, use the graph from problem 1. How much would you expect to pay for electricity if the average temperature was 70 degrees Fahrenheit? Explain. Well, that doesn't have anything to do with what we have here, so we have to backtrack. So let's go back and look at the information from problem 1. So looking back at this, it asked us, what would we expect to pay if our temperature was around 70 degrees. So 70 would be right about here. And so if we look up through the data, we're looking in this range here. So we'd probably be looking to spend right around, I would say, $170. So we can use this data to kind of extrapolate what a cost would be as well. So we go back here. So the answer to question B would be right around $170 if our temperature were 70 degrees Fahrenheit. And we can use that. And you may recall from Algebra 1 the idea of a trend line, where we fit a line to the data to help us determine what the trend of the data is doing. So if we were to put a trend line over this data, we would see that it would be something along this line. And so that's where I get my 70 from. It would hit right around, or 170. So for 70 degrees, we're hitting right about here. So it's close to $170 in cost if your average temperature is 70 degrees Fahrenheit. But instead of spending a bunch of time with just basic trend lines, we're going to talk about something else. We're going to talk about line of best fit and correlation coefficients. And we're going to talk about how to find that information using the TI graphing calculator. So the line of best fit is a trend line that gives the most accurate model of related data. And luckily for us, we have graphing calculators, which are very good at finding the line of best fit. So we're going to do a linear regression to find the line of best fit equation. And when we're doing that, we also then want to calculate the correlation coefficient, or the R value, which indicates the strength of our correlation. The closer that R value is to 1 or -1, the more accurate our model is likely to be, and the more closely grouped our points are going to be. All right, so the closer to 1 or -1, the stronger positive or negative correlation you're going to have. So before we start using our calculator to find our line of best fit, the first thing I want to do is we have to turn on a particular setting or a diagnostic setting to make sure that when we go to calculate our linear regression, it also shows us our R value. So in order to do that, turn on your graphing calculator. With your calculator on, there are two ways to turn on the R value. So if you're using a TI-84, you can click Mode. You can then go down to the second screen, or the second page, so you go all the way down till you see, well, in this case, this one doesn't have it. Oh, sorry. Go down till you get to Stat Diagnostic, sorry. And then you're going to turn this on. So turn on Stat Diagnostic, and then that's going to allow you to see your R value when the time comes that you calculate your linear regression. If you do not have that on your mode settings, you're going to have to go a longer, more roundabout way, and you're going to press the second button followed by the catalog button, or 0. So you're going to press second 0, and you're going to scroll all the way down until you see diagnostic on, and you're going to hit enter, and that's going to turn on your diagnostic for your stat diagnostic. Then hit enter again, and you're good. So now we can go about calculating our linear regression the way we want to. And so here I've just posted an example of how, in your book, they illustrate how to do this. And we're going to walk through this example with the book, and then we'll do one on our own. So for this one, the first step, it says, use the stat feature to enter the data in your graphing calculator. Enter the X values for years in L1 and the Y values price in L2. So first thing we want to click is the stat button. So we click stat. We're going to click, and we're going to go edit. And in the L1 column, we're going to put the years. And so for this, I'm going to just use 1998 as the first year. So I'm going to put a 1 there. And then for 2000, I'm going to put, that's the third year because we skipped 99, so we'll put 3. Then 2002 is 2 years later, so we'll put 5. 2004 is 2 years later, so we'll put 7. Then we'll put 9, and you get the idea. And so then in the L2 column, we want to put the average cost per gallon of milk in this case. So we're going to type in, start with 2.65. Oh. Then we're going to do 2.89. Then we're going to do 3.00. And then 3.01. And then 3.2. and 3.7, missed the point, 0.77. All right, and so now we have our information in the stat feature. We got them in the list. We're good to go. So now we just got to run the linear regression. So to do that, we're going to hit stat. We're going to go to the right to the calculate menu and go down to option 4, lin reg. And so we've got our X is the L1 list, Y is the L2 list, and we're going to hit calculate. And then our calculator is going to spit out the information we need. And so we should notice that if we've done this correctly, what we have matches what they got out of the book. So we did it right. So we're on the right path. We're also then going to notice that our equation for line of best fit, they provide it to you in slope-intercept form, but they break apart the values. So what that means is they're giving you information in the form y equals ax plus b, and they're giving you values for a and b. So the a value, y equals, let's say, they say 0.09, let's do 93 for now, plus the b value, which is 2.5, 2.53 is good. And so this is our line of best fit. Let's rewrite that. That should be a 3. And so this is a line of best fit. And it's essentially what they got here. They rounded a little differently than I did, but not by much. All right, and so the other piece that we have here is our wonderful R value, our correlation coefficient. And since we can see that the correlation coefficient in this case is right around 0.92, which makes it fairly close to 1. So this line is fairly accurate. All right, so that's a good one. It's really close to 1, so we're doing pretty well. All right, so that's what we're looking at. If it was like 0.5, it's real iffy there. Not great. All right, so we're going to try this again with one more practice problem. So make sure you're following along and trying it in your calculator as well. So for this example, the table lists the cost of 2% milk. Use a scatter plot to find the equation of line of best fit. Based on your linear model, how much would you expect to pay for a gallon of 2% milk in 2025? So we're going to enter the information here, create our equation for the line of best fit, and see how close and accurate it would be. All right, so let's go ahead and start entering information. So as we go back to our stat, so we go to the stat menu, we're going to go to edit again. Notice here we have things in our list, so we can just go up to the L1 and actually clear it out. So we go up to it and hit clear, and if you hit back down, it clears it out. You can do the same thing for L2, clear it out. And now we're going to enter the information into our L1 and L2 columns. So in the L1 column, we want to put years, and we're going to go and assume 1998 is year 1, so we're going to put a 1 here. And then we go to 2000, so that would be a 3. And since it goes from 2000 to 2002, this would be 5 years later, 5 years after the initial year. And then 2004 would be 7. Then we've got 9. And then we've got 11. Then in our other column here, we're going to go ahead and put our average cost per gallon now. So we've got 2.57, 2.83, and then 0.93, and then 3.1, and 3, I skipped one somewhere. Oh, there's two 2.93s. So go back up, 2.93. You got to be careful as you're typing these in. Sometimes you're going to miss one. So always make sure you're double checking. All right, so now we've got our information all entered into the calculator. We're going to run our linear regression. So we're going to hit we're going to hit stat. Then we're going to hit over to the right, calculate, and we're going to go down to lin reg. We're going to hit enter. Our L1 is our X values, our Y1 is our Y values are our L2, so we're good. L1 is X, L2 is Y. We're going to go down to calculate, and it should calculate our linear regression and our correlation coefficient, or our R value. So in this case, the calculator is telling us, if we are talking about our line of best fit in this form, y equals ax plus b, that our equation for our line of best fit would be y equals 0.093 x plus 2.45, and our r value is 0.91-ish, right around 0.91. So we are fairly accurate. It's a really good, pretty good fit for the data. And so the second part of this says, how much would you expect to pay for a gallon of 2% milk in 2025? So 2025 is essentially, 27 years after 1998? If 1998 is number 1, 2025 would be 27 after that. So if we plug in 27 here for x, we should be able to calculate that value. And if we type this in our calculator and let our calculator handle it all, we should get our answer to be right around $4.96. So we're going to try one more example. This one's a little different. We're going to try to find the line of best fit for the relationship between calories and fat in this particular set of data. So once again, we're going to go back to the stat menu. We're going to go to edit. We're going to edit our L1 column to deal with number of calories. And then in this case, we're going to do L2 as grams of fat. All right, so we're going to enter this information and see how we do. So L1, we're just going to enter the information. So take a minute, enter the information, and then we'll go from there. So now that I have the calories entered into my L1 column and the grams of fat in my L2 column, I'm then going to run my linear regression. So I'm going to hit stat. I'm going to go to the right on the calculate menu, go down to lin reg. And then I'm going to, all right, X is calories, so that's L1, we're good. Y is grams of fat, that's L2, good. And then we're going to go down to calculate and we're going to hit enter. And then it's going to spit our information out to us. And so for this one, our line of best fit equation should be y equals 0.07x minus 9.27. And then once again, we'll notice that our R value is fairly close to 1, so this is a good match for the data. So 0.946, our data is grouped tightly, pretty closely together, and this line would be a good fit for that data.